Okay, so make a reference here to the previous exercise. And so what we've got here is rho equals sine phi, right? And conveniently, in that previous exercise, it tells us what this is. So this is the rotation around the z-axis of a circle of radius a half in the xz plane centered at blah. Yeah. Okay. Okay. So let's draw that picture. So again, it's just given that. Let's see here. So we've got circle of radius 1/2 and the see you later. Yeah. Centered at 1/2. Okay. So it's this circle in the xz plane rotated around the z-axis. And so what you've got is what I like to call a fat bagel, right? It's a bagel. It's so puffy it doesn't even have a hole in the middle anymore, right? And it's I'm not gonna be able to make a good drawing of it.
Yeah, I know.
Yeah. Do you know what I'm talking about? Yeah. So I'm gonna make a bad drawing of it just to have something. Kind of, something like that. Okay, so we want to use a spherical coordinates integral to compute the volume. So it instructs us. Okay. Right. So well, it's going to be a triple. Hang on. Triple integral of 1. That's how we compute volume. dV is rho squared sine phi d rho d phi d theta. So that's most of the integral that I need to compute. Now I just have to worry about bounds. Good news, we already know that this is a rotation all the way around the z-axis, so that means theta goes from 0 to 2 pi. Yeah? Okay. Let's see, phi. All right, let's focus our attention on a particular value of theta. Well, for a particular value of theta, and I'll draw it over here. Yeah, the whole point was, from the previous exercise, that this is a circle, right, or a disk. And this disk on that disk, now let's make sure to note where the origin is. The origin there, here. And so let's start drawing different values of phi. Well, phi starts at 0. And it just keeps going all the way down until we get to pi.
Yeah.
So 0 to pi. Yeah. Cool?
Yeah.
Okay, and then lastly, for a given value of theta and for a given value of phi, now we look at let's see, I'll do this in yellow. There's my range of values of rho, right? So it's going to starts at 0 and it ends at that point, which is on that curve, which is on this surface, which has that equation.
Yeah.
So in this equation, solve for rho. And that gives us 0. Again, we started at 0 and ends at sine phi.
Thank you.
Yeah, no worries. Everybody else happy with that? Okay.
And